Good morning, everyone. Today, we are going to solve a few more problems related to natural response and forced response. And after evaluating these two of them, we are going to find out the total response of the system. Okay, let me share the screen now. Okay, yes, the one of the problems where it has been given like this, which is the forced response the forced response the forced response of a system to a sinusoidal input to a sinusoidal to a sinusoidal input to a sinusoidal input is termed as is termed as is termed as steady state response is termed as steady state response is termed as steady state response. Evaluate, evaluate, evaluate the steady state response. Evaluate the steady state response of the system. Steady state response of a system considering considering the following system. Considering the following system. Considering the following system. Now, how is the differential equation? Y dash of t plus y of t equals cos t u of t. As I already told you earlier, so this is the differential equation model. Okay, so once you are going to model this differential equation, so you are having a sinusoidal input that is being termed to find out. So once you are having the input as sinusoidal, okay, so the input, it is not like sin t. So once I'm having the sinusoidal input, I'm going to have the cosine function also can be represented using a sinusoidal function. Okay, so the forced response of a system is called as the steady state response of the system. It is being modeled in such a way that it is y dash of t plus y of t equals cos t into u of t. Now the solution goes this way to find out the steady state response. As I already told you, the steady state response the steady state response is equal to the forced response of the system is equal to the forced response. As I already told you, natural response without considering the input. Now with the input being included, you are going to have the forced response of the system. Forced response of a system. Fine. So now, if I want to find out how would the forced response of the system, the structure of the forced response system, how would it look like? Considering the input signal to be cos t u of t. It is a right-handed signal, the u of t, and x of t is cos t. Now, given input x of t equals cos t into u of t, how would the forced response of the system would look like? So the forced response of the system would look like C1 cos omega is 1 here. I can write it as t 1 into t omega t. Okay, plus C2 sin t. This is the structure of the forced response. YF of t. Structure of the forced response. Structure of the forced response. Now, I have this structure of the forced response being given. So now what I would like to recall is y dash of t plus y of t equals cos t. Now, y dash. So I can write it as yf dash of t plus yf of t. That would be equal to cos t. Okay. Now, yf, that is forced response being differentiated once, what it would look like? Cos t differentiated, it would look like sin t with a negative sign plus c2 cos t. Okay, minus c1 sin t plus C2 cos t plus C1 cos t plus C2 sin t, that would be equal to cos t. Okay, now I can group the terms. It is quite simple now. Now C1 plus C2 times cos t, okay, plus C2 minus C1 times sin t, that would be equal to cos t. So plus 0 into sin t. I can write it like this. Now what I can equate the constants here as C1 plus C2 equals 1, C1 plus C2 equals 1. Next, C2 minus C1 would be equal to 0 on equating the constants. On equating the constants. Hope it is clear to you. On equating the constants. Now, I have C1 plus C2 equals 1 and I have C2 minus C1 equals 0. So, C1 equals C2. Fine. So, later on I will be having C1 equals 1 by 2. Okay. Next, C1 equals C2 equals 0.5. I can write it like this. Now, the forced response of the system that would look like is 0.5 times cos t plus 0.5 sin t. This is 0.5 sin t. So this is the forced response of the system. So in order to evaluate the forced response of the system, one should identify the structure of the forced response for a given input and then proceed with the given initial conditions. If it is not given, you can take it as 0 and then you can also find it, and later on you can have the substitution option also being done to calculate the forced response of the system. Forced response of the system. So this is how it would look like, the forced response, that is 0.5 cos t plus 0.5 sin t. Okay, I hope the solutions are quite clear before we move on to the next problem. So moving on to the next problem, the problem is given like this. Let y2 dash of t plus 3y dash of t plus 2y of t, that would be equal to x of t, where t would be greater than or equal to 0. Okay, for t greater than or equal to 0, initial conditions given, that is y of 0 equals 3. Next, y dash of 0, that is equal to 4. Okay, y dash of 0, that is equal to 4, and y of 0 is 3. So these are the initial conditions given. These are the initial conditions given. As I already told you, these are the initial conditions. Once it has been specified, you can carry out and then you can find out the response of the system. Find its response. Find its response if x of t is 4 times e power minus 3t, and the second input, after applying the first input, the second input that you can apply to the system, where it is given as 4 times e power minus 2t. 4 times e power minus 2t. So once I talk about the response, it is generally given as response here. I don't know whether it is a natural response or forced response. In such case, find its response. You have to calculate the total response of the system. Total response of the system. Total response of the system. Okay, I think it is quite clear to everyone. Find its response, meaning you have to calculate the total response of the system. So y total, you have to find it out as yn of t plus yf of t. Okay, so that's how you can calculate the total response of the system. Okay, next, take the differential equation that has been given there, y2 dash of t plus 3y dash of t plus 2y of t, that would be equal to x of t. Given the initial conditions, y of 0 equals 3, y dash of 0, that would be equal to 4. Okay, now what is the first step to find out the natural response? the natural response. The natural response, that is yn of t. You have to find out the natural response of the system, yn of t. How would the system would look like, right? So in order to find out the natural response of the system, first thing what you are going to do is to find out the characteristic equation. To find out the characteristic equation, that is s squared plus 3s plus 2, so with input being not applied. Okay, so in order to find out the response, we have to neglect, or input should be equal to 0 in order to find out the natural response of the system, or the transient response of the system. Now I have s squared plus 3s plus 2. The roots you can find out easily using a calculator, scientific calculator. So s1 is equal to -1, s2 would be equal to -2. Now in order to find out the natural response, as I already told you, that is k1 e power minus t plus k2 e power minus 2t. So this is -1 here, as I already told you. That is minus t. Okay, so I can write it as k1 e power minus 1 into t plus k2 e power minus 2 into t. So that's how I can find out the given roots of the equation, the natural response of the system. The natural response of the system can be found, or can be applied using the roots of the equation. Natural response of the system. Natural response of the system. That is yn of t. That would be equal to k1 e power minus t plus k2 e power minus 2t. That is the natural response of the system. So that's how you can able to find the natural response of the system. Now let me keep it aside as of now, as I take the natural response in finding out the total response later on. Now if the input is applied, I'll be going for the forced response of the system. These are quite easy for everyone. Given forced response of the system, the structure of it, you can able to find it easily. Now y2 dash of t plus 3y dash of t plus 2y of t, that would be equal to a given input, that is 4 e power minus 3t. So this is the given input for the input x of t, that would be equal to 4 times e power minus 3t. Okay, for the given input 4 times e power minus 3t. Very important step keep in mind in the remaining solutions to the given problem. Look at the characteristic equation roots, that is -1 and -2. Is it same as that of alpha here? No, it is not same as that. The forced response of the system, the structure of the forced response of a system with the given input that is being there, you can able to write the forced response of a system as c e power minus 3t, or k3 e power minus 3t, the constant whatever that is being present there, right? So now I need to differentiate this equation twice. Okay, so the first thing what I do, I differentiate it once. C e power minus 3t I can write it, and minus 3 being multiplied, that is minus 3c e power minus 3t. Okay, next yf2 dash of t, that is equal to, what I can do, I can differentiate this minus 3c e power minus 3t into minus 3. Okay, that is 9c e power minus 3t. So that is yf2 dash of t. That is how you can get yf dash and yf2 dash of t. So differentiating it once and this one twice. Okay, yf dash of t, that is equal to minus 3c times e power minus 3t, yf2 dash 9c e power minus 3t. Next, I can equate it here, e power minus 3t, 9c e power minus 3t plus 3 into minus 3c e power minus 3t plus 2 into 2c, this one, this is yf, 2c into e power minus 3t, that would be equal to 4 times e power minus 3t. Now again the same steps here, 9c minus 9c, uh, that is there, plus 2c, okay, times e power minus 3t, that would be equal to 4 times e power minus 3t. Okay, 9c get cancelled. Okay, so the value of c would be equal to 2. On comparing, you can come to know that the value of c would be equal to 2. So what is the forced response there? How you can find out the forced response? You can find it as 2 e power minus 3t. You can find it out as the forced response of the system. The forced response, the forced response of the system, the forced response of the system. Okay, so that is yf of t, that would be equal to 2 times e power minus 3t. So that is the forced response of the system. Next, I know the natural response of the system. I can have k1 e power minus t, if you can recall, k2 e power minus 2t. I have the natural response of the system. So in order to find out the total response of the system, that is yf of t plus yn of t. So you have natural response with zero input being applied, and forced response where the input is being applied and the structure of the forced response is to be found out depending on the input. Okay, now what I can do now is I can just add both of them. So I'll be having k1 e power minus t plus k2 e power minus 2t as the natural response. In order to have the forced response, this one is the natural response, this one is the forced response, what I'm writing now, that is 2 times e power minus 3t. Okay, now what needs to be done here? If you verify it carefully, this is y total. The constants, okay, the constants k1 and k2 is to be found out. In order to find out the constants k1 and k2, you have the initial conditions being given. They will be specifying it very clearly. I repeat, they will be specifying it very clearly in order to find out the total response of the system. Okay, y of 0 equals 3 and y dash of 0 equals 4. These two are the initial conditions for the evaluation, or for to find out the evaluating the total response of the system. Evaluating the total response of the system. Total response of the system. Okay, now I have the system being given, that is y of 0 equals 3, y dash of 0 equals 4. Now y total, what it would look like, k1 e power minus t plus k2 e power minus 2t, then you have the other one, which is plus 2 e power minus 3t. Okay, so I want to find out what is k1 and k2. Okay, so I will give y of 0. Okay, I'll give y of 0. So what it is at t is equal to 0, the given equation y total. So what happens when t equals 0, k1 plus k2 plus 2, that would be equal to 3. Okay, so k1 plus k2 equals 3 minus 2, that is 1. k1 plus k2 equals 1. I repeat, so y of 0 will have 3. So I give t is equal to 0. I'll get k1 plus k2 equals 1. So this is the first set of equation to find out the given two unknowns. As you already know that the number of initial conditions would be equal to the number of unknowns that are being present there to find out the solution for k1 and k2. Now, next one, what do I do? I'll differentiate this equation. I'll differentiate this equation. So what do I do? Y dash, that is the total response, that is k1 minus 1 e power minus t plus k2 e power minus 2t into minus 2 plus 2 into minus 3, 2 into minus 3 e power minus 3t. Okay, so next what do I do? Minus e power minus t into k1 plus minus sorry minus 2k2 e power minus 2t minus 6 e power minus 3t. Okay, so I can rewrite this equation again in like straight line. Y dash total, that would be equal to minus k1 e power minus t minus 2k2 e power minus 2t minus 6 e power minus 3t. Okay, so that's how you can able to get y dash total. And to find y dash total, okay, so we have differentiated the equation that has been given with forced response and natural response. Don't just differentiate this one. I have seen it, like most of them will go wrong. You just evaluate this function and leave it the last function. Okay, that's the forced response, you just leave it. That should not be done. And this is how we can able to get y dash total. Okay, so keep these two concepts in mind, and you are going to have the next one, which is y dash total, y dash sorry y dash total, that would be equal to, okay, I can recall it here, minus k1 e power minus t minus k1 e power minus t. Okay, next what we have here, minus 2k2 e power minus 2t minus 2k2 e power minus 2t. Next, what do I have the third function, which is minus 6 e power minus 6 e power minus 3t. Okay, so I have y dash total would be equal to minus k1 e power minus t minus 2k2 e power minus 2t minus 6 e power minus 6 e power minus 3t. Now, initial conditions of y dash of 0, that would be equal to 4. So what's the input that you are going to apply? X of t, that would be equal to 4 e power minus 3t, the first input. Keep this in mind. Okay, so you are doing it for the first input. You are later I'll tell you how to do it for the second input, right? So now what needs to be done here? So you have 4, that would be equal to minus k1 minus 2k2. Okay, next you have minus 6. So where t is being equal to 0, you are going to get 4 plus 6, 10, that is equal to k1 with a negative sign minus 2k2. Okay, so later on you are going to have k1 plus 2k2, that would be equal to minus 10. So this is the second equation. I can recall the first equation what I derived earlier, which is k1 plus k2, which is k1 plus k2 equals 1. So this is the set of the differential equations that you are going to find out, and you are going to find out the values of k1 and k2. Okay, so finding out the values of k1 and k2, you can generally go for the approach what you are going to have there. So in order to find out the values of k1 and k4, it would be quite easy to use a calculator, and the value of k1 is found to be 12 and the value of k2 is found to be minus 11. Okay, so you can just substitute it and you can check it out. So the value of k1 would be 12, the value of k2 would be minus 11. So the output of the system, y total, okay, y total, the output of the system would be, so how would it look like? So it would be k1, that is 12 e power minus t. Next, what you are going to have, plus k2, that is, what is the value of k2? Minus 11 e power minus 2t plus 2 into e power minus 3t. 2 times e power minus 3t. Okay, so that's how you are going to get there. So y of t, that would be 12 e power minus t minus 11 e power minus 2t plus 2 e power minus 3t for t greater than 0, greater than or equal to 0. So this is how you can find out the given response of a system, the total response of a system that is being present there. Okay, so now for the second input, what is to be done is, I'll just give you a hint, that is, for the second input, x of t, that would be equal to 4 times e power minus 2t. So what you are going to do here is, you are going to have minus 2 here. Okay, e power alpha t, if you can compare, so the value of alpha, what you are going to do, that is minus 2. Okay, so the value alpha equals minus 2 is having one of its root, that is s1 equals minus 1. Okay, next s2 equals minus 2. That these are the roots that we get in terms of the characteristic equation. Okay, so now I have s2 and alpha being equal here. So what would be the structure of the forced response? The structure of the forced response, along with the constant, along with the exponential term e power alpha takes a value of minus 2, you are going to have t term being included to that. Okay, so this t term here, that is being included because the alpha, which is equal to minus 2, and s2 equals minus 2, that is being present there, so coincides. That's the reason why I can include a term called as t. So this is the term which is being included if the root matches with the term alpha that is being present there. So this is yf of t, that is equal to c times t into e power minus 2t. So this is the structure of the forced response. The structure of the forced response, the structure of the forced response takes the form of takes the form of yf equals c t e power minus 2t, yf equals c into t e power minus 2t for the given input, for the given input for the given input x of t equals 4 times e power minus 2t. For the given input x of t equals 4 times e power minus 2t. Okay, so that is what you are going to do, and then you are going to find out what is y of t. Then you are going to find out what is y of t. Okay, I'll assign this problem to Nishana. So she's going to find out what the total response given x of t equals 4 times e power minus 2t. Okay, with this session, I would like to end the class. In the next class, we are going to find out the total response of certain systems being included in terms of differentiation and other inputs. And later on, we are going to proceed with a concept called as zero input response and zero state response. It is also a quite simple topic. And later on, we are going to proceed with the solution to difference equations. Okay, so see to it that you are going to cope up with the pace that I'm teaching right now, and this would certainly increase in the coming classes. Okay, so with this note, I would like to thank everyone for listening to this lecture. Thank you.